Hey, it's Mr. Springer. I am in Indianapolis grading those lovely AP exams you took last week. So I left you this little packet on acids and bases. Hopefully it won't be completely new to you, but at the same time it won't be a complete waste of time. So the first page here is on conjugate acid-base pairs. What you need to remember is that the acid has one additional hydrogen ion or proton or H plus than the base. So when you're going from the acid to the base, you take away an H and you take away a plus 1. So here was the H2SO4, which was neutral. It ends up HSO4 minus because you took away one of the H's and you reduced the charge by 1. The equation that you're going to write is just the acid, equilibrium arrow, the H plus that you plucked off, and the HSO4 minus that you're left with, which was the conjugate base. I'll do a couple of them. H3PO4 we reduced by an H and a plus. So it'll be H2PO4 minus, obviously. H3PO4, equilibrium, H plus, H2PO4 minus. Let's try this one down here at the bottom, number 7. We got SO4 with a minus 2. I want to make the acid of that, so I'm going to add an H plus. I'm not balancing the charges, I'm just adding an H and a plus 1. HSO4 from minus 2 to minus 1. Notice this is one additional charge higher than this. That's all there is to this page, except at the bottom, which is the stronger base. On the first question, which is the weaker base. On the second question, I would make all of those into their conjugate acids. And just know this, that if the conjugate acid is a strong acid, then its base will be a weaker base. And I'll leave it at that. Next page is called pH and POH. This one is painfully, embarrassingly easy. Notice that whatever the pH is, the H plus is to that power but negative. And the pOH is that power but negative. If pH is less than 7, it's acidic. It's more than 7, it's basic. 7, it's neutral. They shouldn't have written it that way, but they did. So not at all difficult. Just remember that pH plus pOH has to add up to 14. So here we got a 10 to the minus 2, so the pH will be 2. If pH is 2, pOH is 12, right? 14 minus 2 would be 12. So this would be 10 to the minus 12, and that would be, since pH is 2, 2 is less than 7, acid. Easy peasy. Next page, pH and pOH continued, gets a little more difficult. A little more. All you're doing is finding the negative log. Well, okay, there's a couple things. Some of them are acids, some of them are bases. You can tell the difference, right, between the acid and the base. We're always calculating the pH, even though it says pH and pOH. The answer is going to be the pH. You may have to calculate the pOH to get there. But on the first one here, strong acid HCl 0.01, negative log of 0.01 would be 2, pH equals 2. Number 2, 001, negative log of that will be 3, but this is a base, so that would be pOH equals 3. 14 minus 3, pH is 11. Be careful on number 3. There are 2 OHs coming off from each formula unit of calcium hydroxide. So what are you going to do there? Right? What are you going to do? The OH minus concentration is not going to be 0.05. It's going to be something other than 0.05. What are you going to do? Third thing you want to be looking at is these that are weak acids or bases, and they're giving us a percentage dissociation. Let's do number 7. It says 10%, so 10% of 3 would be 0.03 molar. We do negative log of that. We'll get 0.52, I believe. Where'd it go? Yep, there it is, 0.52. Be aware if this was of a strong acid rather than a weak acid, then 3 it would be like it'd be a negative 0.47 or 57 or something like that. So much more acidic. This only 10%. Okay, so that one shouldn't be too much trouble. Well, the next stage is a little more complicated. It gets into some new, although antiquated, concepts of normality. Okay, you remember molarity, which is moles per liter. Well, we're doing normality, which is equivalence per liter. And equivalent is just the number of H pluses or OH minuses that can come out of a formula. So if it's monoprotic, which means only one H plus or one OH minus, then normality equals molarity. If it's not, then let's see, normality equals molarity times the subscript. And if you need molarity, then it'll be normality divided by the subscript. So let's do a couple of these. Here's the formula. We're using normality times volume, acid, base. So 25 milliliters of HCl, that's an acid, that's the volume of the acid. Titrate it to the endpoint with 15 milliliters of 2-normal NaOH, that's the base. I'm going to plug into this equation. I'm going to do the algebra in my head. Na, Nb, Vb, Va, plug and chug, 2.0 normal times 15 milliliters. Okay. Ordinarily, would we want to change these to liters? We could, but to change them into liters, you're going to be multiplying or dividing each by 1,000. So we'll be dividing this by 1,000, dividing this by 1,000. It's just going to cancel. And since they're both in milliliters, we can just cancel the milliliters and everybody will be happy. 2 times 15 over 25 should be 1.2 normal. And since the first question was the normality of the HCl, so there's 2 blanks, was the normality. What's its molarity? Well, if it's HCl, monoprotic, normality and molarity are the same. Makes sense? Number 2, 10 milliliter sample of sulfuric acid, that's an acid, Va. Notice that's a diprotic acid. It was exactly neutralized by 13 milliliters of 1 molar KOH. But molar, right? We want normal. Only 1 OH, so it's the same thing. And it took 13.5 milliliters. So I want to know the normality and the molarity of the acid. I'm going to go ahead and do the normality first because that's what's in the equation. Normality of the acid will be the normality of the base, volume of the base over volume of the acid. Milliliters cancel. 13.5 divided by 10, 1.35 normal is the acid. Yeah? Normality was second. I put that in the second blank. I know the normality. I want the molarity, so I'm going to divide the normality by the subscript. 1.35 divided by 2. There's the 2. 1.35 divided by 2, 0.68 molar. Could be 675. Hard to tell. They do goofy things with significant digits on this paper. All right, one more and we'll be done. How much? 1.5 molar NaOH. Again, monoprotic. So the normality of the base, OH is a base, 1.5 normal. Necessary to neutralize 20 milliliters of 2.5 molar phosphoric acid. Volume of the acid will be 20 milliliters. Now, molarity, we want normality, so 2.5 times 3, 7.5 And we're looking for how much, so volume is what we're looking for. The normalities are going to cancel. I'm going to do the algebra in my head. I'm looking for VB, which will be NAVA over NB. And 7.5 divided by 1.5 should be 5. 5 times 20 is 100. 100 milliliters needed. So, a couple more problems there you can do. They're very similar. I don't like, one thing I don't like is they're using the word endpoint when they should be using the word equivalence point. But nobody's perfect. Alright, the third page. Third page? Fourth page? I don't know. Fourth page. Fifth page? Fifth page. Okay. What we did in the lab the other day, we're doing hydrolysis of salts. And so all you got to do is just divide the salt into its cation and anion, K plus, Cl minus, NH4 plus, NO3 minus. Do that for all of them. And then we're going to add enough H's, H pluses, to balance out the charge of the anion, the negative ion, and enough OH's to balance out the charge of the cation, which is the positive ion. This time charges do matter. We want them balanced. Everything turns out good. If it's both strong, it's be neutral, one of each. That'll be either acidic or basic. If they're both weak, you can't tell. So, the parent acid for this one will be HCl. Parent base will be KOH, both strong, neutral. Let's do a harder one. Here's one. Na, we got plus 1, PO4, minus 3. So I need H3, PO4. Right, not just HPO4 minus 2, it's H3PO4. And Na is a plus 1, NaOH. Weak acid, strong base, basic. Good enough. Do the rest of that page. You ought to be good at that by now. And the last page is a little crossword puzzle. There are a couple things I would like to point out on the crossword puzzle. I don't know how much we've talked about H3O plus. I believe we've mentioned it. Remember, that is the hydronium ion. On number 13, can act as either acid or base. They're using the old school way, which I like. Amphoteric. And number 9 down, no, number 15 down. When equivalent amounts of H plus and OH minus have reacted at a titration, the authors of this packet used the wrong word there. It should be equivalence. Equivalence point, but they use end point. Okay, good luck with this. You ought to be able to get most of this done in the rest of the period. And see you next time.